Hey there everybody, Mr. Mark with you. And in this quick video, I want to discuss with you the atomic mass unit. The atomic mass unit, which is abbreviated 1 AMU in my system, how I learned it, the official designation on your formula chart is just 1U, is defined as 1/12 of the mass of carbon-12. And the history behind that is kind of interesting. Briefly, we originally tried to define 1 AMU to be the mass of one hydrogen atom. But then when we tried to apply that unit to other things, the numbers just didn't work out. And today we know it's because of mass energy equivalence. The more stable a nucleus is, the less mass it has, more energy has been converted to the binding energy of the nucleus. And so eventually we kind of settle on carbon-12 and then we realize what was actually happening. But that's just why it's defined as 1/12 the mass of carbon-12. So speaking of mass energy equivalence, what I kind of want to show you real quick is how you can convert this to an energy, like in a nuclear reaction, kind of quickly. And I'm going to kind of start this by showing what this looks like for a kilogram. So if we apply mass energy equivalence, E equals mc squared, and we use a mass of 1 kilogram, and then of course c squared is 3 times 10 to the 8th meters per second squared, you would get an energy of 9 times 10 to the 16th joules, which is an astonishing amount of energy. It's the power behind nuclear reactions. And so you could almost kind of use that number as a conversion factor. So for example, if we were going to convert in a nuclear reaction 2.5 kilograms of massed energy, I could kind of just go, for every 1 kilogram, I would get out 9 times 10 to the 16th joules. That's the correct conversion factor. And then, just doing some quick calculating, you get like 22.5 times 10 to the 16th. And so if we're converting kilograms to energy, we could just kind of use that number as the conversion factor. Well, we can also do that with atomic mass units. So if you look at your formula chart, the definition, excuse me, the conversion of one atomic mass unit to kilograms is 1.66 times 10 to the negative 27 kilograms. So if we kind of do the same calculation with that number, so instead of 1, if I use 1.66 times 10 to the negative 27 kilograms times the speed of light squared. So when you do that, you get a number that's approximately 1.5 times 10 to the negative 10th joules. So you remember learning about the electron volt, which was kind of like the energy unit for photons and electrons and things like that. We can kind of relate atomic mass units to electron volts using a conversion factor kind of like this. So if we take that number right there, about 1.5 times 10 to the negative 10th joules, and if you don't round it, it's actually 1.49 something something something. And then you convert it to electron volts. So 1 electron volt is 10 to the 1.6 times 10 to the negative 19 joules. Then you get a number that's about 9.34 times 10 to the 6 electron volts. So keeping in mind that this number right here, this is directly from the physics 2 equation chart, is a little bit rounded. So this number is just a little bit bigger than the commonly accepted value. That's approximately equal to 931, and then 10 to the 6 is mega. So mega electron volts. So on your equation chart for physics 2, there is the very last line on the bottom of all the table of constants, a line that looks like this: 1 AMU, or 1U, 1 atomic mass unit, is equal to 1.66 times 10 to the negative 27 kilograms, which is equal to 931 mega electron volts. So if you convert one atomic mass unit of mass to energy, this is the energy that you will get out. And so this is a more useful system for nuclear reactions than joules in a lot of cases. So oftentimes, instead of using kilograms, we will use atomic mass units, and then our answers will be in mega electron volts, which we could easily convert to electron volts. So kind of like in a nuclear reaction, let's just suppose for a second that our delta M, our mass loss, was, let's just say 1.2 times, well, let's just do 1.2 AMUs. Keep it simple, which is kind of a lot. Okay, so if we were to want to know how much energy we're going to get out of that, we could just multiply it by this 931 conversion factor. So every one atomic mass unit, we get out that much energy. And so multiplying 1.2 by 931 would give me the energy in mega electron volts. So that'd be like 11,017 MeV, or mega electron volts. So now when you see that unit, either U or I still kind of, this is how I learned AMUs. Now you know how to quickly convert that to energy if you are looking at a nuclear reaction. I hope this quick little lesson was helpful for you. Until next time, ta-ta.